Now that we have broken down our application into two different services, we have introduced one other issue. And across all the videos, you can see the same pattern over again. You fix one problem, there is another problem to be solved. And the problem over here is the different endpoints. Previously, you had one application, one monolithic application where you have one endpoint, and through that endpoint, you are hitting that application and you are hitting both the users API, analytics API, and activities API. Now that you have broken down this into two different services, that means you have two different endpoints. Well, you can say that the client can call both of these endpoints independently for both these services that we have right now. In this particular case, that is fair, but what happens when you have tons of other services involved? In this example, I showed you only two. But when you go at the scale of Microsoft Teams application or any other applications that are out there, you have tons of different services that are involved. And the client cannot know about each and every service and its endpoint. So how do you fix this endpoint problem? How do we know which endpoint to hit? This is where we introduce API gateways. The idea over here is that the client no longer talks directly to the services. We're not sharing the services endpoints with the client, but we are sharing the API gateways endpoint. It's a single point of entry for all of our clients. If previously our endpoints were handling the authentication, rate limiting, and logging all on their own, now the gateway can do that. The gateway can not only act as a single point of entry, but it can also do the authentication, the logging, the rate limiting for you, which means we can now remove all the redundant code that we had for handling authentication for each and every single endpoint and move that to the API gateway level. Here you can see that I'm spinning up a quick API management resource on Azure. And basically this is an API gateway on Azure itself, which also does load balancing for you. And over here, I'm configuring all the endpoints that we have and indicating that if we see incoming requests that have user in it, we can route that request to whichever machine the user service is running on. And if we see a request with the analytics or activities in it, we can route that request to a different service which has the analytics or activities service running on it. And now, as always, when we run our load test this time, through our API gateway, we can see that the API gateway acts as a single entry point distributing traffic to our other services. We know that the user service is taking more traffic and it's compute heavy. So when we look at the CPU of the machine on which the user service is running on, we can see that its CPU usage is higher compared to the analytics and activity services. What this has done is it has made our service clean by removing all the redundant code that we had, act as a single point of entry to our services such that our client does not have to worry about communicating with the service directly, but just communicating with this API gateway.